I will begin by discussing vulnerabilities associated with unsecure protocols. Network security is never a completely done deal. It often seems as if as soon as one hole is plugged, another one opens up. Vulnerabilities are discovered all the time, making it difficult for network administrators to keep up. While this is true, there are still some steps that administrators should take to reduce the vulnerabilities that exist in the systems under their control. By reducing known vulnerabilities, administrators can then spend their time preparing for and reducing exposure to up-and-coming threats, thus increasing their productivity. The first vulnerable protocol that we're going to discuss is Telnet. Telnet is a protocol that is used to create a virtual terminal connection that is commonly used for troubleshooting. Telnet is very unsecure because all communication occurs in clear text. Telnet does not support encryption. Whenever possible, Secure Shell or SSH should be used to create those virtual terminal connections in place of Telnet. Then there is SNMP, Simple Network Management Protocol, versions 1 and 2. SNMP is a protocol that is used to remotely manage and configure network devices. Due to their lack of encryption support, versions 1 and 2 are unsecure and susceptible to packet sniffers. This can allow an attacker to grab those packets and actually gain control of the configuration and management of your network devices. If you're going to use SNMP, version 3 should always be used as it supports more security, including encryption. FTP, or File Transfer Protocol, is a protocol that is used to transfer files across a network connection. While a username and password are required in most cases to use FTP, it doesn't support encryption, which creates a vulnerability in the process. Because of this lack of encryption support, everything is done in the clear, making it susceptible to being captured, and you could lose sensitive information. Secure FTP, or SFTP, should be used in place of FTP as it creates an SSH FTP session. TFTP, or Trivial File Transfer Protocol, is a simple stripped-down version of FTP that doesn't support authentication like standard FTP, so it's even more unsecure. It is commonly used to download and upload configuration files for networking equipment. TFTP should only be used when a connection to networking equipment is made through the console port, thus eliminating the possibility of eavesdropping. And that console port should have its own security measures in place. Everyone's fairly familiar with HTTP, or Hypertext Transfer Protocol. It's the protocol that is used to send and receive data over the internet. It is unsecure in its basic format and susceptible to being intercepted due to its lack of encryption. HTTPS, or HTTP Secure, should be used when conducting sensitive business over the internet, as it will provide encryption and other security services. Hopefully your network still doesn't use Serial Line IP, or SLIP. It is an early protocol that was developed for communicating over serial ports and modem connections that required a static IP address. It is very outdated and very unsecure. SLIP does not support encryption. Hopefully you will be using point-to-point protocol in its place. PPP does support encryption and is much more secure. Now it's time to talk about vulnerable network practices. First up are unpatched or legacy systems. Unpatched systems are by their very nature unsecure. Keeping all operating systems and applications up to date will reduce vulnerabilities in the network, and it helps to harden that network against attack. In some situations, it is necessary to keep legacy systems alive. This can create vulnerabilities in the system, as weaknesses in these legacy systems tend to be well known. Special security measures should be taken with legacy systems in order to reduce the opportunity for exploitation. One of the best security steps that you can take is placing these legacy applications or systems on their own network or on their own virtual local area networks. Then there are open ports, and an open port can either be physical or it can be an application port. These open ports create a hole in the security of the network and may be exploited. While not all open ports can or should be closed, security should be placed on these ports that need to remain open to reduce the vulnerability of the network. A good practice is to use a port scanner periodically to verify that only absolutely required application ports are open. Another thing to remember is that you should only use a port scanner if you are authorized to scan that network, or you may end up in a rather lengthy discussion with your security personnel. Unnecessary running services are another vulnerable network practice. Operating system services are used to perform some functions within the system, but it is possible for them to be exploited. A periodic review of all running services should be conducted on all equipment that is attached to the network. All unnecessary running services should be disabled to harden your network. Clear text credentials are another vulnerability that's rather common. Many applications and devices require the use of credentials in order to be used. In some cases, these credentials are sent in clear text format, which makes them easier to read when captured. A good practice is to periodically review all applications and systems to determine which ones use clear text credentials. Then you need to either limit their use or figure out how to encrypt the transmissions to secure your systems. Unencrypted communication channels are another problem. Any method of communication on the network that is not encrypted is an unencrypted channel that is subject to being breached. While not all communication channels need to be encrypted, a good practice is to review all channels and make a decision about which ones need to be encrypted and which ones do not. All wireless network channels should be encrypted. There are no exceptions. Do not create an unencrypted wireless network. That's just asking for problems. A vulnerability that few network administrators think about are RF or radio frequency emanations. One method of intercepting communication is to analyze signal leakage. That's the RF emanation. Many forms of communication are subject to these signal emanations, but there are steps that can be taken to reduce them. Tempest is a set of standards established by the NSA and NATO that outline steps that can be used to reduce the opportunity for the interception and analysis of communication. I'm going to begin by talking about inside jobs or threats. First up is malicious employees. We may not know the reason why they're malicious, but they are difficult to defend against as they are already inside the defenses of the network. And because they're employees, resources have been granted to them in order for them to be able to do their job. One of the best defenses against malicious employees is using the principle of least privilege, only granting the least amount of authorization that is required for a person to get their work done. That's the best defense against a malicious employee. Compromised systems are another threat. Once a PC or network device has been compromised, it is vitally important to isolate it from the system as a whole. A compromised PC could lead to a completely compromised network, as malware may be able to spread across its connections. Once malware has gained access to network resources, it can be extremely difficult to root out and remove. Malware may also degrade the network's performance, causing other issues. Then there is social engineering. This is the process of using social pressure to cause somebody to compromise a system from inside the defenses of the network. Social engineering pressure can be applied in multiple forms. An employee can receive a phone call from somebody claiming to be from the IT department asking for their credentials. It may occur in person. The social engineering can occur through email or through a rogue website. There are many avenues in which social engineering can occur. The best defense is through end user education. Training your end users to resist social engineering is a good idea. ARP cache poisoning is another threat that can occur on your network. In ARP cache poisoning, the ARP cache, which maps IP addresses to MAC addresses, is corrupted by an attacker, with the end result being that the attacker has control of which IP addresses are associated with MAC addresses. It's commonly used in man-in-the-middle attacks, which I will cover in just a bit. Then there are protocol or packet abuse threats. This is the process of taking a specific protocol and repurposing it to perform a different function. Protocol abuse is commonly used to bypass a router's access control list from inside of a network. An example of this is encapsulating a not allowed protocol within a DNS packet, which is almost always an allowed protocol, in order to get that unallowed protocol out of the network. The man-in-the-middle attack is another threat that you should be aware of. The attacker is not necessarily inside the network per se, but is in between two endpoints that are communicating on a network. In most cases, the man-in-the-middle attack involves disrupting the ARP process between the two endpoints. The attack allows a malicious user to be able to view all network packets that are flowing between the communicating hosts. Often a man-in-the-middle attack is used in an attempt to gain sensitive information like network credentials. Then there's VLAN hopping. This is circumventing the security that is inherent when virtual local area networks are created. Normally, traffic that is tagged for one VLAN is not allowed onto another VLAN without the intervention of a router. VLAN hopping occurs when the attacker adds an additional fake VLAN tag to the network packets. Once the packets get to the switch strips one of the VLAN tags off the packet and then passes it through. Once through the switch, the packet is considered as belonging to the new VLAN, thus bypassing the security that's inherent in VLANs. Now let's move to outside threats. One of the largest threats that face network security personnel is the unknown vulnerability. Network and systems administrators expend vast amounts of time protecting the assets under their control, and they can do a pretty good job of hardening their systems, but it's not a perfect job. The problem lies with zero-day attacks. Zero-day attacks take advantage of either new or recently discovered vulnerabilities, which means that the networks and systems probably haven't been hardened against them yet. The unfortunate reality is that attacks keep changing, and security experts must be willing to adapt in order to keep pace. If they can't adapt, they will fall behind and their networks become vulnerable. Let's talk about the brute force attack. This is using computing power and time to compromise passwords. The attacker uses a program that continually tries different password combinations, often in the form of a special dictionary application, in an effort to crack a password. The best defense against this is to limit the number of times that a user can attempt to log on before they're locked out. Then there's spoofing. This is a category of threats where either the MAC address or the IP address of the attacker has been modified to look like a friendly address in order to bypass network security. A common use in the past was for an attacker to spoof their IP address so that the outside attacker was actually viewed as an inside host. A common defense against this type of spoofing is an ACL rule that doesn't allow an inside IP address to come from outside of your network. Then there's session hijacking. An attacker attempts to take over a communication session after a user has been authenticated. The hijacking can occur through various methods, as in using a packet sniffer to steal a session cookie or installing malware on a user's computer that is activated after the user is authenticated. I'm going to begin by talking about outside threats. Because of how they are implemented, it is often difficult to put network security threats into a single category. Many attempts to breach a network combine different aspects of different threats. For example, a man-in-the-middle attack is often combined with some type of spoofing that is used to help it succeed. That means that in most cases, security requires more than just a single line of defense. Good administrators recognize this and implement multiple layers of security in order to harden and protect their systems. The first major threat that we're going to talk about is the denial of service threat, or the DOS threat. This covers a very broad category of threats to networks and systems. That's because DOS covers any threat that can potentially keep users or customers from using network resources as designed. A traditional DOS attack attempts to flood a network with enough traffic to bring it down. It's commonly used with a flood of malformed ICMP requests. The host that receives the flood can be so busy dealing with the deluge of data that it cannot respond to legitimate requests. Then there's the permanent DOS attack. It's an attempt to permanently deny a network resource for others. It can be achieved by physically destroying or removing the resource, or it can also be achieved through the use of malware that corrupts or damages the underlying digital system to the point where it cannot be repaired and must be replaced. There are also friendly or unintentional denial of service attacks. An unintended DOS attack can occur when poorly written applications consume more network resources than are available. Another unintentional DOS attack can occur when a network interface controller, or NIC, begins to fail. It's quite common when a NIC is about to fail for it to go offline and come back online repeatedly and rapidly. This consumes network resources, which can cause an unintentional DOS. More disruptive than the standard denial of service attack is the distributed denial of service attack, or the DDoS attack. It's a denial of service attack in which more than a single system is involved in sending the attack. A DDoS attack has a higher chance of succeeding due to the increased number of participants. The machines used to send the attack may be voluntary participants, this is called a coordinated attack, or they may be part of a botnet. With the botnet, malware has been installed on the machines and they are no longer under the complete control of their owners. Many distributed denial of service attacks involve botnets where the attacker has actually rented the botnet for the sole purpose of performing the DDoS. The goal of the DDoS is to create a large enough spike in traffic that the target becomes unreachable. In some cases, the target system may need to be rebooted in order for it to come back online. There's the reflective denial of service attack. It's also known as an amplified DOS. The attacker uses some method, usually some form of spoofing, to hide the source of the attack. In a reflective DNS attack, the attacker usually spoofs the intended target's IP address and sends multiple requests to an open DNS server. The DNS server responds by sending traffic back to the targeted system, and the attacker's hope is that the response from the DNS server will overwhelm the targeted system. A cousin to the reflective DNS attack is the reflective NTP attack, or the reflective network time protocol attack. It works in the same way. However, instead of using DNS, it relies upon open NTP servers. Not very common anymore, but you still need to know about it, are the Smurf attacks, also known as Smurfing. It's a type of reflective denial of service attack that also involves spoofing the intended target's IP address. A network is flooded with ICMP requests in which the source address for the requests appear to be that of the intended target. As the replies return, the network becomes slowed down by the traffic. The goal is to overwhelm the target system and bring it down. It's time to move on to wireless network threats. Our first topic is an unintended threat. A common feature on modern wireless access points is Wi-Fi Protected Setup, or WPS. The goal of WPS is to create an easy and secure method for consumers and small businesses to set up a secure wireless network. Unfortunately, the outcome has fallen short of the goal. While WPS does ease the setup burden, it is also easily exploited by an attacker and should actually be disabled on all equipment. This exploit has been known for a couple of years, and you would think that equipment manufacturers would quit enabling WPS by default on their equipment, but that's not the case. So when you set it up, you need to disable WPS. Then there's war driving or war chalking. This is the practice of attempting to sniff out unprotected or minimally protected wireless networks. Once it's found, marks are placed on buildings and streets indicating that networks are available and vulnerable. Something to remember is that wireless networks are vulnerable merely due to the fact that they need to broadcast over the air. Then there's web cracking or WPA cracking. This is using a packet sniffer to capture the password and/or the pre-shared key on a wireless network. Wired equivalent privacy, or WEP, can be cracked in minutes. Wi-Fi protected access, or WPA cracking, will take hours, but it can still be cracked. Neither of these encryption standards should be used on your wireless networks. Rogue access point attacks are another threat that you need to be aware of. This is where an unauthorized WAP gets installed onto the network. Unfortunately, the biggest culprits are the end users themselves. They install their own wireless access points for convenience and then don't properly secure it. This opens a vulnerability into your network. You need to periodically check for rogue access points on your networks, even if you don't have wireless installed. Related to the rogue wireless access point attack is the evil twin attack. A WAP is installed and configured with an SSID that is very similar to the authorized version. As users access the evil twin, their keystrokes are captured in the hopes of gaining sensitive information, like the credentials to log into the actual wireless network. The evil twin attack can also be considered as a type of wireless phishing attack. Then there's bluejacking. Bluejacking is the sending of unsolicited messages over a Bluetooth connection in an effort to keep the target from responding to valid requests. It's more of an annoyance than an actual network threat because it mostly involves the personal area network, which tend to be very limited in their abilities. Related to bluejacking is Bluesnarfing. It's an attack in which the attacker creates a Bluetooth connection with another device without that device's permission. The goal is to retrieve information from the attacked device, as in contact information or stored email. This vulnerability has been patched and may no longer be a concern, but you still need to be aware of it.